Okay, today we're going to look at trig without a calculator again. We're going to look at it to help us solve equations. And again, before I start, I want to talk about something to do with surds, and we're going to chat about rationalizing surds. So when you have a fraction and you have a surd in the bottom, we can rationalize this by taking the surd out of the denominator. And to do this, we multiply the fraction by 1, because when you times by 1, you're not changing anything. Now, timesing this by a 1 itself is not going to help me at the moment because the surd is still going to stay in the denominator. So what I do is I turn the 1 that I want to multiply by into whatever surd is at the bottom over itself. Because this number here that I've just made is still a 1. So you're timesing by 1. You're not changing anything. Okay. Okay, so if I times this by root 2 over root 2, we multiply top with top and bottom with bottom. Okay, square root times square root 2 gives me the square root of 4, or you could say to me, oh, well, I know that the square root of 4 is a 2. So now that means that this is exactly the same as that. It's the same fraction. It's an equivalent fraction. It just does not have a surd in the denominator. Now, we use this sometimes with the trig because we know that in our triangle of 45 degrees, if I say to you, what is the cos of 45, you would tell me it's adjacent over hypotenuse, which is 1 over root 2. Now, I can rationalize this, just like I did the previous example, by taking that and multiplying by root 2 over root 2. So instead of writing 1 over root 2, I could go 1 times root 2 is root 2. And root 2 times root 2 is the square root of 4, which is root 2 over 2. So the cos of 45 is 1 over root 2, but it can also be written as root 2 over root 2. So you're going to find that a lot of your special angles can be rationalized. So if we were using 30, okay, here's our 30-60 triangle. 1, 2, root 3. Tan, TOA, is opposite over adjacent. So for 30, opposite is 1, adjacent is root 3. Right, now again, I can rationalize this. I can take the surd out of the denominator by timesing it by root 3 over root 3, which is a 1. So 1 over root 3 is exactly the same as root 3 over the square root of 9, which is 3. So these two are equivalent, the equivalent surds. Okay. All right, so that was rationalizing denominators. Another one that can be rationalized is a tan of 60. Okay, so for tan 60, again, TOA, opposite over adjacent. So opposite, root 3, adjacent, 1. Okay, now that one, obviously, sorry, that one doesn't need to be rationalized because there's a 1 at the bottom. Apologies. Okay, so what about sine of 60? Okay, sine of 60 is opposite over hypotenuse, opposite, root 3, hypotenuse 2. Do I need to rationalize that? No, I don't, again, because it's got a normal integer at the bottom. It's not a surd. So we only rationalize fractions that have surds in the denominator. And to do that, we multiply by the surd over the surd, which is 1, and then we multiply top and bottom, and we rationalize. Okay, so we're going to use our special angle triangles to solve equations now. So this is my 45-degree triangle. 1, 1, root 2. And this is my 60 and 30-degree triangle. 1, 2, root 3. And we're going to use SOHCAHTOA to help us. Okay. So the question would go something like this. Here's an equation. Solve this without a calculator. All right, so what angle do I need to put in here to make this equation true? Well, we all know from the other day when we solve an equation, we need to isolate the trig function. So that's the first thing we do. Oh, sorry. Okay, so we're getting this one by itself. So to do that, we've got to add this root 3. So 2 cos theta, or cos x, is going to be equal to 0 plus root 3 gives me root 3. And then we've got one term on each side. We're getting the cos x alone, so we need to divide both sides by 2. So cos x is going to be root 3 over 2. Okay. Now, if we look at our triangles, we obviously are working in the triangle that has a root 3 and a 2, which must be the 30, 60 triangle. Okay, so I'm looking at that, and we know that cos is adjacent over hypotenuse. So in the 30, 60 triangle, which angle has got an adjacent of root 3 and a hypotenuse of 2? Well, the hypotenuse is 2 all the time, so now it makes us look and see. For 60, the adjacent is a 1, so it can't be the 60 that I'm using. It must be the 30. Look here, for 30, the adjacent side is a root 3, so that means I must be using the 30-degree angle to get root 3 over 2, which means that x has to be 30. Okay, so you're kind of using your triangles backwards by trying to work out which angle has a cos that gives you root 3 over 2. Right, let's just try one more quickly. Let's do cos 3x minus 15 is equal to 0,5. Okay. Again, we're going to need our triangles. So quickly, 45, 1, 1, root 2, 1, 2, root 3, 60 and 30. And we need SOHCAHTOA. All right. Okay, so with this one, again, we're solving without a calculator. So the first thing I need to do is get my trig function alone, and it is already alone. Okay, so my first question to myself is which angle has got a cos of 1 over 2? Okay, because we know cos is adjacent over hypotenuse. So which angle has an adjacent of 1 and a hypotenuse of 2? Again, it can't be the 45-degree triangle because the 45-degree triangle has a root 2. And we're looking for a normal 2. So again, we must be working with the 30-60 triangle. So hypotenuse 2, well, that's all the time here. Adjacent of 1, well, it has to be the 60. So that tells me that the 3x minus 15 has to be equal to 60 degrees without using a calculator. And now we're going to solve it like a normal equation and finish it off. So we're going to add 15 to both sides. So 3x is going to be equal to 75. And then finally, we've got one term on each side, so we're going to divide both sides by 3. So x is going to be equal to 25. All right, so we've used just our special angle triangles to solve these equations, and you're going to try some of these for me for homework. Okay, so I thought we must try one more example quickly. If I was asked to solve root 3 tan 2x is equal to 1 without a calculator, we're going to first start solving by isolating the trig function. Each side is one term, so I start by doing inverse operations. This is times by root 3, so I'm going to be dividing by root 3. Okay, so these are allowed to cancel. So tan 2x is equal to 1 over root 3. Okay, if I was using my calculator, I would then jump the tan over and do arctan like we were, but we're not allowed to use our calculator, so we have to use our special angle triangles. All right, so tan is opposite over adjacent, TOA, and if I have a root 3 in my fraction, then it has to be the 30-60 triangle. Okay, because that's where my root 3 is. All right, so tan, which angle has an opposite of 1 and an adjacent of root 3? Okay, so if sorry, I've got these the wrong way around. That's a 60 and that's a 30. Please don't mix those up. Very important that they go in the right place. Okay, so for 60, opposite is root 3, which is not the same as this. So let's try the 30. For the 30, opposite is the 1 and adjacent is the root 3, which means that the angle that I'm looking at that gives you a 1 over root 3 for tan will be equal to 30 degrees. So now I'm going to finish one term on each side. So I'm going to divide both sides by 2. So that means that x is going to end up being 15 degrees. And if you wanted to check it, you could pop it in your calculator to check it. So root 3 times tan 2 times 15 and find out is the answer equal to 1, and then you know whether your equation is right or not if you wanted to check that.